In this session, we'll learn about resonance or mesomeric effect and hyperconjugation. In earlier, we were discussing about displacement of electron in covalent bond, inductive effect and electromeric effect. We are familiar with both inductive effect as well as electromeric. Now, resonance effect also we call as mesomeric effect. In earlier chapter, we come across with the meaning of resonance. In earlier, so we studied this in chemical bonding, right? Many molecules, we cannot able to explain the property with the single structure. With the writing of single structure, we can't able to explain the properties or behavior of the molecules. Due to that, single Lewis structure is not enough to explain this property, means the behavior or structure of the molecule. Hence, more than two structure or the more than two structure proposed, and that hybrid structure means more than 2-3 structures we call as resonance structures. Out of this, the actual structure is resonance hybrid structure. Resonance structures, these are we call as resonance structure. And out of this, the actual molecule is the resonance hybrid structure. Resonance hybrid structure. This phenomena is known as resonance. In this, if a molecule can be assigned two or more structure, for any molecule, if we assign two or the more structure, none of which is capable of describing all the known properties of the compound, then the actual structure is intermediate. Actual structure is intermediate or in between or resonance hybrid of the structure. This phenomena is called resonance. Okay, and this resonance various structure we call as resonating structure, and the various structure we call as resonating structure. We come across with the writing structure like carbon monoxide, carbon and oxygen CO, carbon monoxide, carbon dioxide CO2. And they we have come across with Lewis dot structure. Here the carbon and the oxygen will be having the 6 valence electron, 2, 4, and 6. So carbon and oxygen will write carbon oxygen double bond and carbon oxygen double bond. So this is like this one electron shifts here, no? So carbon oxygen triple bond with single bond as an sp hybridization, not an sp2. That is an sp hybridization, not sp2. Keep in mind, it's exactly like a triple bond. So if you write this is the resonance hybrid structure, stable structure. This we get from the carbon and oxygen. Here the carbon, so 1, 2, 3, and 1 valence electron in carbon 2 and 4. And oxygen 1, 2, 3, okay, and 4, 5. This will be the less than 1 positive charge. For another oxygen will be having sufficient of an electron for this one from carbon, another from oxygen. So the 2 electron, so 2, 4, 6, and additional electron 8 negative charge. This is an negative charge. So, and this also the structure we can also express like this. Oxygen, this positive charge shift left side, no? So oxygen will be having positive charge. So 2 of electron, 1, 2, 3. So 4, 5. So 1, 2, 3. So this with carbon will be having a 1 electron. This another electron belongs to oxygen will be having 2, 4, 6, and the 8, the negative charge here. So these two are the structure. These two structure we can able to write the hybrid structure. For this, I can write like this of all the three structure I'll write together. So in this oxygen, 1, 2, 3, 4, 5, 6 double bonded with carbon and double bonded with oxygen having 2, 4 and 6 structure. Okay, this is the hybrid structure of this two of oxygen 2, 4 and 6 with the carbon. So a negative charge, and the carbon will be having a triple bond with an oxygen forming the dot with a positive charge. Dot positive charge. This hybrid structure means electron transfer of electron will take place and it can able to form. So transfer of electron, shifting of electron from here. So with carbon. So with carbon shifting the triple bond and carbon with oxygen a single bond to 4, 6 and the negative charge, extra electron. So these are how we got this structure because of the delocalization of electron, the shifting of an electron. If the electrons are shifting from means where to double bond, double or triple bonded compound, unsaturated compounds, double bond or triple bonded are unsaturated compounds. So carbon monoxide and carbon dioxide. This already we studied. Similarly, we can able to write benzene. When we take the benzene, and benzene in benzene, so that's double bond, alternate double bond in benzene. No? So carbon, oxygen here. So carbon, 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 here carbon, and this is carbon, and this is carbon, and this is carbon. We'll be having double bond. Here alternate double bond, here alternate double bond, here alternate double bond. This is what? It's a double bond. No, this is pi electron. Here pi electron, delocalization of pi electron. So this delocalization of pi electron. So this can also be right. This is one structure. Here hydrogen, hydrogen, hydrogen. And all valency should satisfy. No. So here hydrogen and here will be hydrogen. So we can also write like this and another benzene. Instead of this, we can write like this. So resonance hybrid structure. We got this resonance hybrid structure from the shifting of electron. If it shifts here, this electron shift here, and this electron shift here, it forms an alternate double bond. Okay, from benzene like this, 1 3 carbon here, 1 2 to 1 3 here. So again 1 2 become 2 3 carbon. If it shifts, no, we'll be getting another structure. So this one, second one, double bond, and here double bond, and here is a double bond. So here electron delocalization of pi electron will take place due to delocalization of pi electron. So more means if the any element or any structure will be getting the more hybrid structure, resonance structure, then the compound is more stable. So this is the benzene how we come across with the writing of resonance structure. Similarly, we can able to write for the other compounds also. We come across with the nitrate, acetate ion, and we can able to write the compound like phenol and other compounds also. So we have to know what is resonance effect. So how this affects the transfer of electron will takes place, whether it is permanent or temporary. Resonance effect is a phenomenon in which the polarity is produced in the molecule due to delocalization or transfer of pi electron from the from multiple bond to an atom or from multiple bond to a single covalent bond or lone pair electrons from an atom to the adjacent single covalent bond. So you need to understand properly what is the resonance structure or what is the resonance effect and mesomeric effect. Mesomeric effect the same as resonance effect. There will be slight difference between mesomeric effect and resonance effect. We'll see later. Okay. So how we say that? Example: you take in a compound like CH2 single bond, CH double bond, CH2. So this we can able to write like this now: CH2 double bond CH single bond CH2. So what happens here? You can notice that if this pi electron means conjugated pi electron shifts here, if this shifts here, so earlier will be deficiency of electron positive, now it will be satisfied, the valency will be satisfied. If this electron shift here, then it forms a positive charge. This carbon forms a positive charge, right? So what happens? So between that carbon, so carbon will be consisting this carbon. So this carbon consisting this carbon having a double bond to that attached to another group. Okay, this is called allylic carbon. This forming a positive charge is called allylic carbocation. Allylic carbocation resonance structure. Okay, so allyl, you need to know properly the difference between allyl and vinyl structure. So allyl and vinyl. So what is the difference between allyl and vinyl? So allyl, we said no, carbon will be having like carbon with another carbon will be having double bond to this compound attached to some other compound. Then this carbon, what we consider is called an allyl carbon. Okay, if this carbon, same carbon attaches to the same carbon, means any substituent group directly attaches to the double bond, then it is called vinyl carbon. Allyl carbon, and this is allyl carbon, and this is vinyl carbon. If the substituent group, example, C here, no, CH3 upon, this is CH, and this is CH2, and this will be CH3. Instead of that, I can replace that Cl here hydrogen, and here one more hydrogen. Another is a Cl group. So Cl group attaches to this carbon. This we call as allyl chloride. Okay, this allyl chloride, and this directly this group consisting of the chloride group CH2, and this will be HCl, Cl, H and CH2. What is this? This is vinyl chloride, anhyl chloride and vinyl chloride. So what is this? Delocalization of pi electron, transfer of pi electron, transfer, delocalization of pi electron from the multiple bond to an atom, or to form a multiple bond to a single covalent bond, or a lone pair of electron from to the adjacent single bond. Transfer of the pi electron. So if it is double bond, carbon with any other group, then it is double bond. So it will be transferred to the single bond, whether it is pi bond or lone pair of electron. Whether either it is lone pair or pi electron, which will be transferred, delocalization of electron will take place. Due to that, the positive and negative charge will form. Due to that, positive and negative charge will form. So it results to complete transfer of electron, forms and positive cation as well as anion. Okay, this displacement of pi electrons or lone pair of electrons. Electromeric effect is what? This is a resonance. Sorry, mesomeric effect is same as resonance effect. Resonance involves in displacement of pi electron, displacement of pi electron or lone pair electrons, lone pair electrons. It operates only in unsaturated conjugated system. Unsaturated conjugated system example should have the double bond. Double or triple bond should be a conjugated system, should be an alternate system. Then the replacement of electron means a delocalization of electron will takes place from one carbon to another carbon, means the pi electron or lone pair of electron will delocalize. So that must be consist the conjugated system. Okay, and move along the length of the conjugated system. If you consider in the case of inductive effect, this affects maximum till to the 3 carbon. Okay, after the third carbon, example, the halide group can attract, this effects is can able to slightly, we can notice till to 3 carbon. After that, this effect is insignificant. Inductive effect is insignificant after 3 carbon. But in the case of resonance, it can be takes place throughout, as many as carbons are there, the conjugated system. But the complete conjugated system, it will be affected. It will be affect or move all along the length of the conjugated system. Okay, so resonance effect. What is the resonance effect? Is a phenomena in which polarity is produced, positive and negative charge is produced in the molecule due to transfer of pi electron from multiple bond of an atom to the single covalent bond. Single covalent bond or lone pair of electron to single covalent bond. Okay, are you getting? So resonance effect is seen as a electromeric effect. So to the adjacent single covalent bond, there will be transfer of an electron. So here in delocalization, what are the important features of mesmeric effect? It's an operative in unsaturated compound, especially having a conjugated system. So we'll be having an unsaturated compound like carbon-carbon double or triple bonded system, and should be in a conjugated, especially conjugated system should have an alternate double bond, double or triple bond, then the conjugation will be please. Okay. Next, after this will be a permanent effect, and this present in the molecule in ground state. Permanent effect will be present in stable state of the molecule. It involves in complete transfer of pi electron or lone pair of electron. So full positive or negative, complete positive or negative charge will be formed, and it affects the physical properties such as dipole moment and solubility and etc. Okay, so resonance effect, what is? It's a phenomena which polarity is produced, charge will be produced, positive and negative complete charge will be produced in the molecule due to delocalization, transfer of pi electron from the multiple bonds to a single bond, or from lone pair of electrons to the single electrons. Okay, and this will be, and it also affects the physical properties such as dipole moment and solubility. Okay, so it involves in the transfer of pi electrons or lone pair of electrons. It is a permanent effect. Okay, you need to remember. Next, so this mesmeric effect or resonance effect divided into two types: plus M effect or plus R effect, positive mesmeric effect or positive resonance effect. So the group which donate electrons to double bond or to the conjugated system or to the conjugated system are said to have the positive M effect or positive R effect. So positive resonance effect. So I hope you are knowing the resonance effect or mesomeric effect. What is positive resonance effect? Example, I'll write, take a compound. This one, CH2 double bond CHC. Okay, so in ethyl chloride, what will happen? This one, CH. This will be carbon and chloride. So here, this what will happen to that? So tendency, substituent has a tendency to donate electron to the double bond. Substituent have a tendency to donate electron to the double bond. This substituent will be having the pair of electron, means the more electronegative. No? So here there will be chlorine having the electron. So chlorine will be having an electron. So one will be forming 2, 4, 6. Okay, with bonds to form 8 electrons. So if it donates an electrons to this, then what will happen? This electron cloud on this will be increases because it forms a double bond. One more electron density will be increases. Due to that, this double bond shifts to and this carbon. So we can able to write, we'll write like this, and it will shift. Carbon will be forming CH2. So will be extra pair of electron unknown. So carbon will be having negative charge. Then carbon hydrogen. And between this carbon will be forming Cl, chloride, and carbon will be forming double bond with the positive charge. Will be the pair of electron will be shifted. No, here 2 electron, 2 and 2, 2, 4 and 6. Out of this, what will happen? Out of this 6 electron. So I'll write any 6 electron. This is example 2. So need not to get confusion. This is 6 electron. Okay. So here the 6 electron, 2, 4, and the 6 electron. So out of this, what you are noticing, you need to observe properly. Here, 2 electron and 2 electron and 2 electron. This 2 electron contributes to this. On the carbon, the electron density will be more. So 1 electron shifts to this carbon. So due to that, this carbon will be having negative charge and the pair of electron on it. And due to this transfer means this fluoride is electrons to this, hence it will be forms a double bond to the first carbon between carbon and chloride. So what happens to this chloride? The substituent group will be having getting the positive charge. Substituent, what the attached group will be having the positive charge. This is called positive resonance effect or positive mesomeric effect. So substituent has tendency to donate pair of electron or electron to double bond. It should donate electron to double bond or the conjugated system. The conjugated system or double bond which is donate, then the effect is called positive resonance effect. Which are the group can able to show positive in positive means electron donating group, electron can donate to the double bond or which act as a positive resonance effect, OH group. Okay, OH, OR group, then NH2 group, this NH2, next NHR group, NHR group, okay, NH2 group, then NR2 group, okay, then Cl group, then Br, then I. This shows plus R effect. This shows plus R effect because of electron rich node. They can easily donate to the conjugated system or double bond can able to form positive resonance effect or positive effect. So I'll write one example to that. I'll write one more example to this. So C6H5NH2. What is this? Aniline. C6H5NH2 is called aniline. Okay, this is an NH2 group. NH2 group and can able to donate pair of electron to the conjugated system. Okay, this 2 electron. If these 2 electron donates to here, so I change the color and write these 2 electron donates to here, this carbon between nitrogen and carbon. What happens to this double bond? This double bond will shift here. Okay, means this point. Okay, I'll write this point where if this 2 electron cloud increases, no, then the double bond will shift to this cloud. So if these 2 electrons shift to here, we'll be having the extra electron density. This point is more. If this point is more, then what will happen? This electron shift to here, and if it shift here, already it has a double bond. It will be getting like this. So I'll write completely. I'll write the structure. I have to notice here. Okay. So the benzene C6H5 NH2. Okay, and then in this NH2, so if I write 0 inside the 0 is not suitable, I'll write alternate double bond in it here, here, and here. Okay, then the resonance hybrid structure. So if these 2 electrons shift, you need to observe carefully. If these 2 electrons shift, this will shift here, and this double bond will be pair of electron on this ortho position. If it is in the ortho position, then the double bond, we can write like this, no? And this double bond. See, if it forms a double bond, pair of electrons here, nitrogen, NH2, will be forming positive charge because it donates an electron. So between 1 and 3, there is no carbon density, right? Next, after that, here, the pair of electron will be having the pair of electron, will be having the pair of electron is negative charge extra. If this electron, due to this, what will be the structure? This is and the pair alternate double bond, and this will be the alternate double bond, right? So what happens if this electron shift here? This electron shift here. These two pair of electrons shift here, and this will be forming the double bond on this corner. Means and para position will be having a double bond. So I'll write another structure. So and this, if this double bond will shift here, on this will be having the pair of electron. So I'll write with the different colors here. So here there will be pair of electron is negative charge. Pair of electron, then negative charge. This will shift here, no, will be having negative charge. What will be the ball? Will be having an alternate double bonds, and this will be having NH2. NH2 will be having a positive charge. Okay. Next, if this electron will be delocalization of pi electron or lone pair of electron. If this electron shift here, if this electron shift here, then this will shift to this pair of electron shift on this position. Okay, again from an ortho position, beta to ortho position. So we can get a structure like this here. The spell array isn't right. So we'll have a structure like this here. So here will be the lone pair of electron. Here will be the lone pair of electron here in double bond. Okay, here is double bond and here is double bond. Will be negative charge. Here also negative charge. And alternate here NH2, NH2, and will be a nitrogen will be having positive charge. Now also having alternate double bond. Then what happened? This electron shift here, and again this pair of electron go back to on the nitrogen. Will be getting the first structure. Will be getting as it is the first structure. So these are resonance hybrid structure or resonating structure of aniline. Resonating structure of aniline. It is positive resonance effect or plus R effect or plus M effect. Plus R effect or plus M effect. Are you getting? So the shifting of electron, you need to be notice properly how the shifting of electron takes place. Okay, I'll write once again here. The nitrogen will be having an alternate double bond. Sorry, benzene having alternate double bond. Now it is an aniline. Hydrogen is replaced with NH2. Okay, now this you need to understand properly. Will be having the pair of electron. If the pair of electron shift to here, no, I'm not writing shifting any arrow marker. Just I'll writing the double bond where the double bond will be shifted. So if the shifting of an electron from here, then shifting of electron will take place, and this ortho position will be having negative charge, and between nitrogen and carbon will be having positive charge in 2. Okay, and this will be the double bond, one double bond as it is, another double bond as it is. This will be shifting here, and this pair of electrons shift to para position. Then we'll be getting a structure in para position. There will be lone pair of electron, negative charge. Will be having the alternate double bond. Again, the conjugated system retains and NH2 plus positive charge. I'm not writing arrow mark because above I have written the same thing I'm explaining. This will be shift to this meta position, and already have a pair of electron. It will be shift to an ortho position. Then we'll be having a structure. So here in ortho position, the pair of electron. If it shifts, this will be shifting. No, is double bond. Already having a double bond between nitrogen and carbon will be having the double bond positive charge. If this will be shifting here, this go back to its original position. We'll be getting the first structure as it is. So this is how resonance structure means delocalization of electron will take place. This is called positive resonance effect plus R effect or positive mesomeric effect. Positive R effect. Are you getting? Similarly, we can notice that negative resonance effect. Okay, you can notice and you can see the example. No, so here vinyl chloride. So you can notice an example of vinyl chloride. So here you can notice now carbon attaches to this double bond. The double bonded carbon attaches to carbon CH group. To that carbon chloride will be attached. Carbon to that directly it attaches to the double bonded carbon, that is vinyl chloride. If it attaches to this group, means chloride attaches to this carbon, then it is called allyl chloride. So vinyl chloride CH2 double bond CHCl. So CH2 and CH and this Cl. How this will be chlorine? Chlorine can able to donate electron. Now, if we donate electron, how it happens? If I change the color, just you can notice here. So here, chlorine will be donating the pair of electron. So between them, it forms an alternate double bond. If it forms a double bond, this will be shifting. This will shift an electron here. Then on carbon will be negative charge, and between carbon and chloride will be having the double bond. This is a conjugated system. So positive or effect resonance effect, positive resonance effect or positive mesomeric effect. Are you getting? So similarly, so which are the group, which are the group or electron donating group. So we can notice that electron donating group, the vinyl chloride bonded to the double bonded character due to the resonance effect, means carbon chloride CCl bond. Okay, which are the compound shows and plus M effect Cl minus Br minus NH2 minus, because an electron rich, no, it's Br Cl minus I NH2 group OH OR SH and OCH3 SR. These will be having the electron rich. This electron rich group, no, so can easily donate an electrons to the neighboring carbon. If it donates a neighboring carbon, the alternative carbon will be having the single bond shifted to a double bond. The shifting of pi electron will be takes place. This leads to the formation of resonance effect. The two positive resonance effect or positive mesomeric effect. So plus M effect or plus R effect. So group, these are the responsible group, the electron donating group, which can donate electron to the alternate double bond. Understand properly, can able to donate electron to the alternate, means electron to the neighboring carbon. Okay, so you'll be thinking the electron, which are the group more electronegative, they can drag the pair of electron. Why is not dragging here? We'll be having an alternate double bond. Due to this, means already it's unsaturated compound. This will be insufficient, means compared to this and this can drag the pair of electron. Few of the compounds will be having, the few of the substrate group will be having, those can drag even due to the presence of double bond. Even in the double bond, they'll having more tendency to drag the pair of electron. So that is opposite to this effect. That is called minus R effect. Okay, so negative, we'll notice that what are the, which are the groups are electron withdrawing group, tendency to withdraw the double bond. Electron withdraws from double bond or conjugated system. Okay, so we'll notice, no, we'll see that next minus R effect, minus R effect or negative resonance effect. The groups in which withdraw electrons from a double bond or from conjugated system towards itself due to the resonance is said to have minus R effect. Need not to get confusion with the electron donating group and electron withdrawing group. Here, the groups should can able to drag the pair of electron from double bond, and the group can able to donate electrons because they can't able to drag the pair of electron from the double bond. So these are electron donating group because they cannot able to drag the pair of electron from the double bond, unsaturated compound. The few other group, okay, can easily drag the double bond electron from the double bonded or unsaturated carbon. So we'll take an example, no? So cyanide, ethyne cyanide, or you can take any nitrile compounds, cyanide compounds. So CH2 double bond CH. So single bond between them, carbon and nitrogen. In this case, CN group, carbon and nitrogen is triple bond. Okay, in nitrogen, what will happen? So pair of electron, it drags a pair of electron towards itself because of resonance effect itself. If it drags a pair of electron itself, then what happen? This conjugated double bond shift to the next one, next electron, because it will be forming positive charge, no? So we can able to write like this. So second structure is CH2. If shift an electron, carbon will be having positive charge, and between them this electron will be shifting, no, this carbon, between this carbon and carbon, carbon hydrocarbon will be having double bond, CH and C will be double bond, and between carbon and nitrogen that also forms a double bond. So between the carbon CH and C, so right, CH and C double bond, and between carbon and nitrogen that is also forms a double bond, and will be having the lone pair of electron. So it's negative charge. So this is called minus R effect, negative resonance effect. Which are the groups are attached? CN group is attached to this. What is that CN group? CN, CO, CHO. Okay, CN, CO, CHO, C double bond O, no, ketonic group. C double bond O, that is CO is nothing but. And NO2 group, NO2 nitro group, okay, then aldehyde group of CHO, then the group of COO or carboxylic group. This shows minus R effect because they can drag the pair of electron from the unsaturated compound or double bonded electron or pi electron. So these can show minus R effect. This can show minus R effect. For this also, I'll write one compound. Okay, C6H5NO2. Okay, nitrobenzene. So take an example of nitrobenzene. I'll write here C6H5NO2. This is NO2 group. In the case of nitrobenzene, we'll be having nitrogen and oxygen. So I'll write NO2 separately because the electron withdrawing group, not an electron donating group. Okay, nitrogen, oxygen itself, NO2 group itself is undergoes a resonance, will be forming alternate double bond. So N will be forming positive charge. In one oxygen will be negative. Here is another oxygen. Will be having the two pair of electron, two pair of electron. This is NO2. So what happens in this case? If it happens, this pair of electron, if it drags, so this pair, I'll change the color and write. So this pair shift to here. This pair shift to here. And this double bond will be shifting here. If we are getting the shifting of an electron, so we'll be getting a structure like this. So shifting of this electron, due to that, will be forming double bonded with nitrogen N, double bonded with nitrogen N plus, will be forming oxygen O minus, and will be forming oxygen O and minus, will be forming here 2 plus 2, 6 electron. So pair of electron shift here. So X is electron. Between the nitrogen and carbon forms double bond on nitrogen. Will be having the double bond on nitrogen. So what happened? So here the vacancy, electron vacancy created, no. So vacancy created, due to that, what happened? There will be less of electron density. Less of electron density, positive charge, which carries positive charge. If it carries positive charge, then left behind as it is the pair of electron. That is an alternate double bond. So due to this positive charge, this double bonded electron will shift to here. If this double bonded electron shift to here, then these electron will come. Then positive charge will be in the para position. If the pair of electron comes here, then what? How the structure will be getting? Then positive charge in para position. So N benzene, this is double bonded NO2 group. So NO minus and O here and minus. So here this positive charge shifted to here. This will be the positive charge. Okay, this will be positive charge. So you can notice this shifts, no. So double bond here, one double bond, and here will be the double bond. Here there is no change. Here this will be shifts to here. So we'll be getting the double bond here. So here positive charge, the positive charge shifted here. Then what happened? This positive charge shift here. So is nothing but then positive charge. Why the positive charge shift here? Because this pair of electron will shift here and positive charge. This will move to and this position will be getting a structure like this, and here in this group positive charge in ortho position. So in this we'll be having double bond, same NO minus and NO here also minus. And this no shifting of charges. This electron shift here is double bond, here is double bond. This will be the positive charge. This will be the positive charge here in positive charge para position. So what happens? This positive charge delocalized electron move to here, and this pair of electron again comes back to this position. We'll be getting the first structure. We got the first structure, not just the first structure. This is the first structure. Okay, so we are getting like this. This is minus or effect, negative resonance effect. Okay, this is negative resonance effect. You need to practice this. Otherwise, it's very difficult for you to write. Just you need to practice how, not a practice, you need to understand how to write this. I said no, vinyl chloride. Carbon attaches directly to the cyanide group. Double bonded carbon attaches to the CN group. So what happens to what happened in this group? So yeah, we notice no here what happens to this group of CN nitrile group. So this double bond will shift here because this will be carbon, this pair of electrons shifted to nitrogen. So nitrogen will be having negative charge. At carbon, this carbon will be having positive charge and it forms a double bond. This is minus R effect, negative resonance effect. Negative resonance effect because the substituent group is electron withdrawing capacity. CN group is more electron withdrawing group. Not only CN group, I said that CHO, CN, NO2, COR, these are having a tendency to drag the pair of electron from unsaturated carbon. Okay, shows minus R effect. And the compound will be shown NO2, CN, C double bond O, CHO, COO, and SO3H. This compound will shows minus R effect, negative resonance effect and positive resonance effect. The difference between negative resonance effect and positive resonance effect, plus R effect. Okay, what is plus R effect? Will be consisting the electron donating group, substituent electron donating group can able to capable of the drag pair of electron from unsaturated compound. Carbon will be consisting unsaturated double bond or lone pair of electron. To that it needs to donate, it needs to satisfy. Okay, to that next carbon will be having an so alternate single bond. No? To that it has to donate an electron. So then this will shift here, carbon will be forming negative charge. So in the case of minus I effect, reverse. It is an electron withdrawing capacity. What the group are attached, the taking away. If the taking away, the cleavage will be takes place. In the case of electron donating and electron withdrawing group. So how the plus R effect and minus R effect change takes place, you need to know. Withdrawing, electron withdrawing capacity, electron withdrawing. So the difference between inductive effect, what we used, negative inductive effect, and here resonance effect, you need to notice. In predominant inductive effect and resonance effect is more predominant than the inductive effect, because both the inductive effect and resonance effect is acting in a same chemical reaction, then resonant effect is more predominant. Why this? Because of carbon-carbon unsaturated compound. But in the case of inductive effect applicable to 3 carbon, that to carbon-carbon single bond. So there is sigma electron transfer. But in the case of resonance effect, there is pi electron transfer. Okay, so this is the difference between plus R effect and minus R effect, or plus M effect and minus M effect. So almost the same, mesomeric effect and resonance effect are almost the same. Okay, then what is the difference between resonant and mesomeric effect? There is a slight difference between the resonance and mesomeric effect. What is it? A slight difference? Although both resonant and mesomeric represent the same phenomena, they differ in their following respect. How? Resonance involve all type of electron displacement. Resonance, you notice that carbon monoxide, carbon dioxide, which may consist in single bond or double bond, whatever it is, in all the type of displacement of electron will be takes place. while in mesomeric noticeable only in the case of multiple bond in conjugation with the multiple bonds. Conjugation with multiple bonds or electron pair should have an alternate double bond or triple bonding should consist in the unsaturated compound. Unsaturated compound in such cases will be noticing the mesomeric effect, and in all the process whether we'll be having a single bond and double bond, no problem, the transfer of electron, then it is mesomeric effect, the same as a resonance effect, but this is resonance effect because this should be consist and alternate means conjugated system to say it is a mesomeric effect. So both are same. There will be slight difference. Only the difference is what in mesomeric effect that should have the multiple bonds in conjugated system. But in resonance, all the displacement of pi electron in the unsaturated compound takes place. That's we call as resonance effect. There is a difference between the resonance effect as well as mesomeric effect. Okay, so the third one, earlier the first one, inductive effect, next electromeric effect, next resonance effect. Okay, now, so next is plus R effect of OH group in a phenol and NH2, especially for the benzene compound. I have written no phenol and NH2. Phenol C6H5OH is phenol. C6H5NH2 is called aniline. How the electron, this OH group, no OH group, whether it is an electron donating group or electron withdrawing group. OH shows positive resonance effect, right? Because it can donate the pair of electron to the double bond. If it donates a pair of electrons to the double bond, then what will happen? If it donates a pair of electron to that, then it will be shifting. The pair of electron will be shifting now. So what you are noticing, OH oxygen phenoxide ion C6H5O minus is phenoxide ion. OH oxygen and hydrogen. On oxygen there will be pair of electron. This pair of electron shift to the carbon, this carbon, because it can donate an electron and on the carbon, then this will be delocalization. Delocalization of the electron, pi electron will be takes place. If this electron, I have written already in the earlier, so with the different colors, the same are given here. So if this shift here, no negative charge, then what happens? This double bond will shift here, means this electron will shift here. In para position, it will be getting the pair of electron. In this para position, again, it will be continuous. This pair of electron shift here. This double bond moves to again in ortho position. In ortho position, will be having negative charge. And this ortho position after this electron, lone pair of electron or pi electron shift to the carbon, nitrogen, oxygen double bond. Then what happens? This again retains to oxygen. Retains to it phenol position as it is C6H5OH and phenol group phenolic position. Okay, so first group, first structure as it is in the last structure 1, 2, 3, 4, 5. No, fifth structure will be the same because again it will be retained. The same thing will be happening. I have written in right side, but what they given in left side. Okay, so NH2 group, the same as an NH2 also because it donates an electron. No? So same delocalization of electron will takes place, and you need to understand properly, not practicing actually. You need to understand properly how the electron will be shifted. Okay. So similarly, and minus R effect also, as like in plus R effect, we'll be noticing the minus R effect, especially in the C6H5NH2 aniline, as well as an aldehyde group CHO, benzaldehyde C6H5CHO. And both are electron withdrawing. If they are taking away, electron taking away, then what happens? Then positive charge will be delocalizing. Delocalization of positive charge from the ortho positions to a para position, from para positions to again and the virgin from the same attached group, and the first structure itself will be getting the same structure. So this is minus R effect and plus R effect. You need to be noticed properly, and you need to understand this also how the resonance effect will be takes place, whether the plus R or minus R effect. Okay, is it clear? Is it clear? So minus R effect as well as plus R effect. So that whether in aliphatic compound or aromatic compound should have an unsaturated compound in that. So delocalization of electron will take place. Clear? So the next, as like we studied inductive effect, electromagnetic effect, and resonance effect. The next is hyperconjugation. Hyperconjugation is also known as no bond resonance. The word itself, no bond resonance or Nathan Baker effect. No bond resonance or Nathan Baker effect. This will be noticed by Nathan Baker, hence it's called Nathan Baker effect. No bond resonance is nothing but there will be transfer of sigma electron here. The transfer of sigma electron when attached to group, then carbon consisting of hydrogen, carbon consisting of an hydrogen itself, we call an example hydrogen, no? This carbon will be having like this, carbon will be consisting hydrogen. So will be represented the first carbon, if we consider from the attached group, first carbon, second carbon, third carbon, then it consists in hydrogen, then it is called alpha hydrogen. First carbon is an alpha hydrogen, second carbon consisting hydrogen, beta hydrogen, next gamma hydrogen, delta hydrogen, or etc. Okay, where the group attached, where we are considering the first carbon consisting hydrogen is an alpha hydrogen. The first carbon attached to that is alpha carbon. Okay, so in this hyperconjugation, what is in hyperconjugation? Why it is non-bonded? Why it is called as the no bond resonance? So here sigma bond will be formed, break and forms a multiple bond. Hyperconjugation is a permanent effect, which is a permanent effect involves in delocalization of electron of carbon hydrogen bond, CH bond, of an alkyl group directly attached to an atom of unsaturated system or an atom with unshared p orbital, whether it has an unsaturated compound or unshared p orbital. That you need to know, unshared p orbital. The electrons of carbon hydrogen bond of alkyl group enter into partially conjugation with the attached unsaturated system or with unshared p orbital. Unshared p orbital. So how we can define this also? Interaction between, this is the interaction between electrons of pi system. This is the interaction between electron of pi system and adjacent sigma bond. Adjacent sigma bond. Okay, and single bond. Sigma bond is carbon hydrogen single bond, right? And the substituent group in organic compound is called hyperconjugation. This is called hyperconjugation. And Nathan Baker rule is also be called as Nathan Baker rule because it was developed by Baker and Nathan as a name of scientist. So in that we'll notice an example. We'll see an example and what is it mean. Okay. So for this, greater the number of carbon hydrogen bond attached to unsaturated system, more will be the electron release in the unsaturated carbon chain. Greater will be the number of resonating structure. More number of resonating structure, then the compound is more stable. Okay, so before entering to the structure, so I'll write an example to this. Okay, example between carbon means an ethyl or propyl compound. Take an ethyl, methyl or propyl compound should be carbon CH3. So carbon, hydrogen. Here is hydrogen. Here hydrogen. This hydrogen. Okay. Then the carbon will be having the CH, carbon with hydrogen, double bond and CH2. So if this is unsaturated compound, in this unsaturated compound, what happens? The alkyl group. In this alkyl group, if an electron, this hydrogen will be having double bonded. If this electron shift to here, then what happens between any one of the electron from carbon hydrogen bond, any one carbon hydrogen bond will break. Sigma bond, sigma electron will break. And due to the breakage of sigma electron will be forming carbon, hydrogen and hydrogen. This is carbon, hydrogen, and this will be forming H plus positive charge. This is the breakage of bond, the first one sigma bond, CH. Okay, and this will be CH2, and double bond will be having the pair of electron or will be having negative charge. Now the electron shifted on this CH2 group will be having negative charge. So what happens to this, whether it's any one structure, not only this, maybe this hydrogen or this hydrogen or this hydrogen will break. But we can notice that the formation of with a multiple bonds, with the formation of multiple bonds, carbon and hydrogen, what it forms in this compound between this carbon and the hydrogen forms double bond. This bond will break, electron shift to here, it forms double bond. Now this will be having a single bond. Whether this hydrogen, this hydrogen, this hydrogen, any one hydrogen, okay, break and will be forming that double bond. This attached group, what it consisting group, attached group, that is what we call as an alpha hydrogen or alpha carbon. In hyperconjugation, the fact of hyperconjugation is same as, similar to that of resonance effect, similar to that of resonance effect. Here there is no bond between the alpha carbon atom and one of the hydrogen atom. No bond between alpha carbon atom and one of the hydrogen. This one carbon attached to this group, no, CH2, any group attaches. And then the hyperconjugation is also called as no bond resonance. Here between the carbon and hydrogen there is no bond. Whether this carbon here no bond, or this carbon no bond H plus, or this carbon H plus with the no bond, this is called no bond resonance. Hence it is also called as nothing Baker. Okay, then what happens, it may notate that the free proton has been shown in the above structure, what we shown in this above structure here. So free proton H plus, what we shown in an above structure, it's still bond but quite familiar with the pi cloud, hence it's not free to move. So due to the unchaining of an electron, means it's unsaturated compound, it's quite sharing with the p orbital, this p orbital, hence it is not free, it's not moving, it will be in the contact with this carbon. Okay, in this what we are getting, the CH3, the hyperconjugation, how we are noticing the tertiary methyl butyl, so or methyl ethyl or other compound, methyl CH3, ethyl C2H5, or the tertiary compound or etc. That hyperconjugation effect decreases with decreases in this order. CH3 will be greater than C2H5 is greater than isopropyl is greater than tertiary butyl or etc. That will be the hyperconjugation. So hyperconjugation, this is in the hyperconjugation, shortening of carbon-carbon single bond will be takes place. So bond, no, if double bond will forms is nothing but the carbon-carbon bond obviously shortened, the bond length will be decreases because the group is attached to that. And if any groups are attached to that group, so what happens, delocalization means the shifting of electron will take place, shifting of electron will take place, that to sigma bond, shifting of electron that to sigma bond, you need to notice it. In hyperconjugation, how is the hyperconjugation, we can notice that the hyperconjugation, the orbital concept, how we can say is that, and how hyperconjugation takes place, and how we can orbital in structurally we can represent. Structural requirement for hyperconjugation, this is a temporary effect. Hyperconjugation is a permanent effect. So shifting of electron, hyperconjugation, it's a no break, so nothing break the rule. So this we consider as the permanent effect itself. So shifting of sigma electrons, no, sigma electrons is it's a permanent effect. In this, what we'll notice, so in the case of unsaturated compound system, especially in a benzene ring or carbon hydrogen single and a alternate double bond, so easily the bond will be break, no, so between them carbon and hydrogen, the bond will break. So you can notice the structural, what are the structural requirement for that? Compounds should have the least one sp2 hybrid carbon. So is nothing but either should have a double bond, either an alkene or alkyl carbocation or alkyl free radical must be. So what are the conditions for the existence structural requirement for hyperconjugation? For the hyperconjugation, the required one sp2 hybrid carbon, either alkene group or alkyl carbocation or alkyl free radical. An alpha carbocation with respect to sp2 hybrid carbon should have at least one hydrogen. With respect to sp2 means and carbon-carbon double bond should have at least one hydrogen. The replacement has to possible. Otherwise, there is no hyperconjugation. So understand properly. In the carbon compound should have at least one sp2 hybrid carbon. So what the compound? Structural requirement for hyperconjugation. Either alkene or an alkyl group carbocation or alkyl free radical. In that alpha carbon with respect to sp2 hybrid carbon should have at least one hydrogen, should consist one hydrogen. Then if both the requirement are fulfilled, then this hyperconjugation will be takes place. We can notice the hyperconjugation. What is the requirement? sp2 hybrid carbon. Okay, and this alpha carbon with respect to sp2 hybrid carbon. sp2 hybrid, no, carbon double bonded. That next, that carbon itself is the first carbon, that is an alpha carbon. Should have an hydrogen, that's called an alpha hydrogen. At least one alpha hydrogen should be there to shows the hyperconjugation. Okay, so what are the structural how hyperconjugation will take place? Sigma and pi conjugation will be divided into a variety types. In that, the two important types will be discussing sigma and pi conjugation. Three types of the. So you need to understand. So sigma and pi conjugation and the how electron will be shifting. That is carbon hydrogen single bond. In this type of conjugation occurs in alkene. So double bonded compound. In alkene, so carbon will be having CH3. This carbon double bonded compound will be having an alpha hydrogen CH3. So in that CH3 alpha, carbon hydrogen, this is alpha. In the case of the CH group, CH3, CH3, this CH, CH, CH2. Okay, in this shifting of electron will take place. Shifting of electron. So hyperconjugation CH3, CH2. In the case of ethyl carbocation or any the carbocations, if we consider no in carbon the bonded minimum double bond in that or in the carbocation, is this double bond, the shifting of an electron will be takes place, right? And similarly in carbocation, C and this will CH3, and having positive charge carbon hydrogen and carbon hydrogen, hydrogen, hydrogen and hydrogen. Here what will happen? This bond will break minimum one hydrogen. From that any one hydrogen bond will break and it will be forming a carbon-carbon double bond. Carbon-carbon double bond. And these two hydrogen as it is. And this will be having an hydrogen but positive charge. No bond between them. And will be having as it is CH2 and CH2. Are you getting? So this is carbocation. Carbocation or in the CH2 group, CH3, CH, CH2. This is an alpha. Alpha means next to that alternate double bond, no? Next to that an alpha, beta, gamma, or etc. We'll be having an alternate double bond. Next to that an alpha. Alpha hydrogen minimum should have an alpha hydrogen, no? So we're having an alternate double bond in alkene with sigma and pi conjugation. This is a sigma. Okay, sigma and the pi conjugation. Carbon will be having the sigma and pi conjugation. Here is sigma and here is a pi conjugation. In case of if double bonded, this carbon will be having the double bonded. To that carbon attached to that is alpha carbon. Doesn't have any hydrogen, no hydrogen, only methyl group. There is no hyperconjugation. To break means to show a nothing like a rule or to show hyperconjugation, it should consist least one hydrogen with a double bonded carbon or sp2 hybridized carbon. That is what we call as sigma and pi conjugation. This type of conjugation occurs in alkene. Okay. So this one, or in the structure, if you write the structure, okay. So in carbon and in carbon, this will be p orbital. So in this p orbital, why this hydrogen will be held it? Because of the p orbital, this p orbital. This p orbital, one is in a sigma, another is delocalized electron. So that is sigma pi hyperconjugation. Due to that, there will be means what is p electron shared means unshared p orbital should be there to show the compound. Means unsaturated is one sigma, another should be pi, no, double bond. between them there will be bond formation, the bonded hydrogen. So it will not move away, or it is not free. That will be inside of the p orbital. That is in force of the p orbital. So there is an orbital representation of sigma and pi hyperconjugation. Are you getting? This is in carbon. Here, no, this carbon, what they are representing. Have to do a white hydrogen. An hydrogen, carbon hydrogen bond will be representing, no, this is ensuring hybridization. It's what you have studied earlier in hybridization. Okay. So it must be required alpha hydrogen. In the case of alpha hydrogen, then hyperconjugation. No alpha hydrogen, there is no hyperconjugation. Sigma means carbon hydrogen single bond and pi conjugation. Similarly, carbon hydrogen sigma and positive charge conjugation. We call it as cation. Positive charge is nothing but cation. So carbon attaches to positive. Next is an alpha, and here carbon attaches to next, both are alpha. So you need to be noticed that alpha means not in only one side. If it attaches to the any of means positive charge to another double bonded compound next to that, no, if double bonded compound next to this carbon attached, this carbon if it attached to, then it is called alpha carbon. The hydrogen, all these hydrogens are alpha hydrogen. Next carbon is beta carbon. Similarly, positive charge is, next to that is alpha. Here positive charge is there. Next to two of carbon, these two are alpha itself. Next, if the next carbon will be consisting, no, this is CH2, CH3. If it is CH2, CH3, and this is CH2, CH3, then this is alpha carbon, this is beta carbon. Then it is alpha and this is beta carbon. Okay. Now, in the case of carbon, here carbon with alpha, and alpha. Okay. In this case, so what will happen? So hyperconjugation will occur in alkyl carbocations, positively charged ions. Alkyl carbocations. So, and the structure, will notice the structure. So sigma and pi charge electrons. Sigma and pi, the charge hyperconjugation is like this. Carbon with positive charge, the p orbital will be having the unsheathed. So in this p orbital, this sigma bond give an electrons to this, will be forming carbon-carbon double bonded compound. These two are dash and wedge model. This dash and wedge model of the 3D representation of the compound. Okay, so sigma carbon hydrogen positive charge conjugation, positive charge conjugation. So hyperconjugation in that. Okay, an application of hyperconjugation. What are the applications of hyperconjugation? Okay, so we'll see the applications of hyperconjugation. Due to hyperconjugation, the shortening of carbon-carbon single bond to the adjacent multiple bond. If you consider to the adjacent multiple bond, there will be shortening of carbon-carbon single bond. Carbon-carbon double here, no, previous it was single bond. Now, if an electron means hydrogen break and electron donates to this, and force of attraction increases between them, the carbon and the length will be decreased. Then the large number of methyl group are linked. The carbon-carbon double bonded. Okay, I said in the case of hyperconjugation. Hyperconjugation, so more tertiary is greater than secondary is greater than primary. Tertiary is greater than secondary and greater than primary is the stability. So here, if larger number of methyl groups are linked to a carbon-carbon double bond, the more number of conjugative means more number of hyperconjugative. Large number, example, carbon will be having carbon-carbon double bond. For this, more the groups are attached. All the groups, no, example CH3. This is methyl group CH3. This is methyl group CH3, and this is methyl group CH3. Then what happens in this? Larger the number means will be getting, so more number, larger stability will be the greater. Further up, stability will be greater. Carbon hydrogen bond is greater than stability of alkene will be stable. More larger the group, then larger will be the stability. Okay, this is about hyperconjugation. This is about hyperconjugation. So we were discussing about what we are discussing. So we were discussing about the displacement of electron. Understand properly all these effects. First one is inductive effect. So inductive effect is a negative inductive effect, positive inductive effect. Next, electromeric effect, positive and negative electromeric effect. Next is mesomeric effect or resonance effect. Positive plus M effect or plus E effect or plus R effect and the minus R effect. Next is hyperconjugation. Hyperconjugation, same as Nathan Baker rule or non-bonded hydrogen. So non-bonded hydrogen should that it should show so carbon unsaturated compound should have at least one sp2 hybridized carbon as well as it should consist or it should consist unhybridized p orbital. Then it can choose hyperconjugation. These are the electronic effect. These are the electronic effect. And we discussed about the attacking reagents like electrophile as well as a nucleophile. You need to know the difference properly also. Electrophile and nucleophile. When the electrophile is attacked and when the nucleophile is attacked, and what will be the reactions. Okay, this is the types of the reactions. Okay, then in a case of the organic reactions, okay, types of organic reaction, which are the types of organic reactions. So organic reactions are important, especially the few important types of organic reaction will be studying here. Those are substitution reaction, addition reaction, elimination reaction, rearrangement reaction. To understand organic reactions, any organic reaction, these are the things you have to know. The name first one itself, substitution. Substitution reactions is nothing but one will be substitute another one of any other group. Example, carbon hydrogens will be there. Okay, we'll see an example for each one. Substitution, the name, understand. First, substitution. Any one of the group will be substituting, replacement will be takes place. Next, addition reaction. Addition means one of the group added to the main chain. One of the group will add to the main chain. And elimination reaction, removal from the group. And rearrangement, within a molecule, the group will be changes its position. The any group or any alkyl group, aryl group, or the carbon related compound will be keep on changing its position within that group only. That is called rearrangement reaction. So organic reaction, we studied organic reaction mechanism also. Reaction forms an intermediate in the presence of attacking reagent. So I'll write neatly. So in the reaction, so reaction to forms reacting to give product in presence of attacking reagent. Here they undergoes an intermediate or transition state. From this we'll be getting along with the product and byproduct. So that is the organic reaction. Organic molecules, reaction mechanism of organic compound in presence of attacking reagent, whether electrophile or nucleophile, it undergoes different transition because as in a transition series will be forming the major product and the byproduct. Major product as well as byproduct. Clear? Next, we'll see one by one. Substitution reaction. And it's a reaction in which an atom or a group of atoms of organic molecule is replaced. Organic molecule is replaced or substituted by another group. Name itself indicates replacement or the substituent. Example, if you see an example, you will understand. CH4 is methane and Cl is chloride. So carbon will be having the 4 of hydrogen. Carbon will be having the 4 of hydrogen. Here out of the 4 of hydrogen, one of the chloride Cl2 group, Cl and Cl, this Cl2. So in presence of sunlight, so chlorination, free radical mechanism will take place. If free radical mechanism will take place, one of the hydrogen is replaced by the chlorine. So this chlorine replaces an hydrogen. If chlorine replaces this hydrogen, then what will happen? Hydrogen combines with chlorine to form HCl. Hydrogen combines to chlorine to form byproduct of HCl and will be forming a major product of CH3Cl, methyl chloride, with the formation of hydrochloric acid. So this is how the reaction, substitution reaction will take place. Hydrogen is substituted by chlorine. Okay, so This also we call as a free radical. Equal means Cl dissociates to form Cl, and Cl chlorine replaces hydrogen or substitute hydrogen. So substitution reaction. Next is in the substitution reaction further divided into majorly the three types. So free radical substitution, electrophilic substitution, nucleophilic substitution. Free radical substitution, electrophilic substitution, nucleophilic substitution. So we studied about the free radical. So homolytic cleavage, homolysis forms the free radical means equal. A and what we studied in earlier, A and B. So AB dissociates equally will be forming A dot. So Fishhook, and another is B dot Fishhook. A dot plus B dot. These are free radical. Okay. Next, heterolytic. Unequal cleavage of organic compound will be forming electrophile and nucleophile, positive and negative, electrophile and nucleophile. Okay, nucleophile, negative charge means electron rich, electrophile, then positive charge. So nucleophilic substitution. So positive charge will be substituted, and the negatively charged group will be substituted, or free radical will be substituting. So the substitution reaction an organic reaction divided into three types: free radical reaction, electrophilic substitution, and nucleophilic substitution. Are you getting? So we'll see one by one. So what is the free radical reaction, electrophilic and nucleophilic? First one, free radical substitution reaction. In free radical substitution reaction, substitution brought about by free radical changes means substitution takes place by free radical halogenation reaction. Halogen group 17 elements. Halogenation reaction takes place. Example, CH4 methane. In the CH4 chlorine, we said first example, no, Cl. All with the carbon and hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. For this chlorine, Cl and Cl group, if this hydrogen is replaced by any one chlorine and another chlorine combined with hydrogen will be forming methyl chloride and hydrochloric acid. So equally Cl dot and Cl dot. So they are separating equally. Chloride, Cl radical and Cl radical will be forming CH3Cl, methyl chloride. Are you getting? So that is free radical mechanism. Similarly, electrophilic substitution. In electrophilic substitution, this reaction initiated by electrophile, electron-rich group, electron-deficient group. Electron-deficient group are called electrophile. CH3Cl, methyl chloride, electron-deficient group in presence of anhydrous chloride. Benzene is treated with methyl chloride in presence of anhydrous aluminum chloride, and will be forming CH3 plus and Cl minus, and this hydrogen will be replaced from benzene, and benzene will be consisting alternate double bond and will be having the 6 hydrogen in all the carbon. Okay, so this hydrogen treat with methyl chloride CH3Cl, it will be dissociated to form CH3 plus and Cl minus in presence of anhydrous aluminum chloride AlCl. So what happened? This hydrogen is replaced by this methyl group. It will be forming C6H5CH3 is called toluene. Along with that, this replaced eliminated hydrogen, removed hydrogen combines with the chloride to form hydrochloric acid. Okay, this is an example for electrophilic substitution. Which is substituted? This hydrogen is substituted by electrophile positive charge, hence it is electrophilic substitution. Okay, next is nucleophilic substitution reaction. Nucleophilic substitution. So electron-rich group are called nucleophile. Electron-rich group are called nucleophile. Substitution reaction initiated by nucleophile. Nucleophile electron-rich group are called nucleophilic substitution reaction. So CH3CH2Br, so ethyl bromide. In ethyl bromide, it will be formed C2H5 ethyl plus Br minus bromide. Treat with the potassium hydroxide KOH. Okay, in presence of aqueous potassium hydroxide KOH. This KOH, what happens? This will be forming C2H5 plus and we are minus. So this will be bromide. This bromide is replaced by attacking reagent of KOH. KOH dissociates to form K plus and OH minus. This OH minus nucleophile replaces bromine and potassium combines with a bromide will be forming KBr potassium bromide and will be forming C2H5 plus, okay, and combines with the OH minus will be forming C2H5OH ethanol with the formation of C2H5OH ethanol and with the formation of potassium bromide KBr. This is an example for nucleophilic substitution reaction. Nucleophilic substitution reaction. Here only you need to notice the difference between electrophilic, electrophile. CH3 is electrophile. Here OH minus is nucleophile. CH3 plus positive charge, electron deficient group. Here OH minus electron rich group. Electron rich group. So can replace this. So any one other group can shows electrophile and nucleophile reactions. Okay. So the types of reactions in this free radical mechanism reaction, like electrophilic substitution reaction and nucleophilic substitution reaction. Next is elimination reaction. So we'll be seeing two types of elimination reaction. One is an alpha elimination, another is beta elimination. Name itself indicates eliminate, removal. So elimination reaction is one that involves in loss of two atoms or group of atoms from the adjacent atom of substrate molecule. What we take the organic molecule, organic reactant is called substrate. From this loss will be takes place. So loss of two or more group of an atom. Atoms are group of an atom. So that is called elimination. Elimination is the two types of elimination. One is an alpha elimination, another is beta elimination. So we'll see the first one. What is an alpha elimination? Alpha elimination reaction is also known as 1-1 elimination. 1-1 elimination. So first carbon alpha will be consisting in hydrogen. In that elimination will take place. See, if the loss of two atoms or group of atoms from the same atom, 1,1 represents alpha carbon. From that, the elimination will be takes place. The substrate organic molecule takes place. It is called 1-1 elimination. So base catalyzed dehydrogenation of chloroform to form dichlorocarbene. Dichlorocarbene CCl2 dot carbene, okay, negative charge. So what happens in this? CHCl3 treat with potassium hydroxide KOH. What happens to that? The carbon will be having one hydrogen and 3 of the chlorine. Out of this, elimination will be takes place. 1,1 is nothing but one hydrogen from this carbon, one chlorine from this carbon get eliminated. Understand? Carbon will be having chlorine, and chlorine 3, CCl3, right? Then is an hydrogen. So alpha carbon. In that 1,1 is nothing but one hydrogen. Dehydrohalogenation. Hydrogen and one halogen get eliminated. If they get eliminated, this will be combined with K plus and OH minus. K plus and OH minus. So what happened? OH and H to form H2O, K plus and Cl minus to form KCl. And what will be the left behind? The left behind is carbon with 2 chlorine, 2 chlorides. So Cl dot and Cl, Cl2C. Cl2C will be having means removal of electron, that is dot. So dichlorocarbene CCl2. CCl2 is called dichlorocarbene with the formation of KCl and H2O byproduct. the formation of the byproduct. This is we call as one elimination. Understand properly why it is one. Hydrogen and halogen from the alpha carbon get itself eliminated right now. So that is alpha elimination or one elimination. Okay. So another is that is called beta elimination. Beta elimination, loss of the two or group of atom adjacent to the substrate molecule takes place. Not the same carbon, next adjacent to that. Okay. So dehydrohalogenation of ethyl bromide. Dehydro, water and halogen. Dehydrohalogenation. So from this, I'll write CH3. This is CH2 and this is Br. And treat with KOH, potassium hydroxide. So hydrogen, hydrogen and hydrogen. Hydrogen and hydrogen. This will be bromide. K plus and OH minus. This will be potassium hydroxide. So this is the substitute group to this. So this is alpha carbon. This is beta carbon. Right? So alpha and beta carbon. So what happens in this? Elimination has to take place. Removal of hydrogen. Next to that adjacent dehydrohalogenation. One is halogen, another is hydro. So one from this bromide. Okay, one is in halogen alpha, another is in hydrogen. So one hydrogen, one halogen removed, no, it forms H plus and Br, this one minus. So K plus, H plus and H2O will be forming water. K plus and Br will be forming KBr. Then what will be the left behind? Carbon with the two of hydrogen. One electron will be left behind, will be forming double bond with carbon with two of hydrogen, will be forming ethene with the formation of KBr, potassium bromide and water. So both we saw, one is in alpha elimination, another is in beta elimination. So beta elimination, that is 1,2 elimination. 1,2 elimination or beta elimination. Elimination will be takes place from the substrate molecule to the adjacent atom. Group of an atom from the adjacent. Removal from the adjacent atom. This one halogen and this is, we'll write, if you want I'll write together. Okay, dehydrohalogenation. To understand, I can write like this also. Carbon, carbon. This hydrogen, 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 here hydrogen, and I'll write Br, hydrogen, hydrogen, hydrogen. This is C2H5Br. So elimination will be takes place from 1 to carbon, beta hydrogen. So elimination, there's an alpha, this is a beta. From this elimination will be takes place now, this bromide, H plus Br to forms an HBr. So, and will be H plus and Br minus. This will be get eliminated. So what will be the left behind compound between carbon and carbon? One electron or one electron will be forming carbon-carbon double bond. Carbon-carbon double bond. H and Br, HOH combines together to form water and Br and K combines together to form KBr. The major product is carbon-carbon double bond alkene. How alkene prepared? By dehydrohalogenation reaction or elimination reaction, beta elimination reaction, we can able to prepare the alkene. Are you getting? So these are the different types of reaction in that. So elimination reaction. The last is addition reaction. Addition reaction. So in addition reaction, substitution reaction, elimination reaction, okay, and addition reaction. What will be takes place in addition reaction? So reaction which involve the combination of the two reactions. The combination, if they add together, so electrophilic addition, nucleophilic addition, rearrangement. In addition reaction itself, divided, we can consider as electrophilic, nucleophilic, rearrangement reaction. In this addition reaction, which involved in the combination of two or more, combination of two adjacent, two or more, the group joined together, molecule form a single molecule, and the product is called addition reaction. So example, hydrogenation of alkene. So addition, so removal, dehydrogenation. Addition, hydrogenation. So carbon-carbon double bonded compound, just now what is an alkene. To that, we can add hydrogen, addition of hydrogen. One hydrogen adds here, another hydrogen adds here. So with addition of this, we'll be forming CH3 and CH3, C2H6. Higher alkene will be forming. Higher alkene with a suitable condition. So that is an addition reaction. In addition reaction, we know that electrophilic addition, okay, and the nucleophilic addition and rearrangement reaction. So electrophilic addition, what is an electrophilic addition? In this, electrophilic part of the reagent initiate in addition, electrophilic part, okay, and a positive charged part in the group. This will be responsible for the reaction, addition of reaction. So Br and Br minus here and Br minus there. So carbon and carbon will be having double bond between carbon, carbon, double bond. Here and hydrogen and hydrogen. Here will be hydrogen and will be hydrogen. So Br will be adds to this one with the Br and one with this Br. Br and Br radical will be added. So it's negative charge. So positive, why this will be adds? Because electron density. So on this electron, 1, 2, 3, 4, here the minimum electron density. So carbon can negatively charge a group can attack here, no? So electron rich group can attach to positive part. So then the positive part is responsible for the addition initiation, and it is called electrophilic addition. In nucleophilic addition, reverse. So HCN, H plus plus Cn minus. So here HCHO is formaldehyde. So HCHO will be forming HC and O, this group. HC and OH group. This what will happen? The negative part initiate to combine this cyanide. CH will be forming the positive charge, and the CN group combines to this will be forming HCCNOH. So what happens? The group will be added. This Cn group will be addition to add it to this hydrogen, means between the negative part OH minus and CH plus part. This will be initiate. Here the positive part will be initiate, and here will be the negative part initiate to responsible for the enhancing to increase the reaction, enhancing the chain of reaction, that is addition reaction. Nucleophilic addition reaction. Rearrangement reaction, which involved in migration of atoms. So here you can notice that C2H5Br migration. This Br will be shifting here to form CH. One of hydrogen shift to here, hydrogen will be shifting and will be replaced by Br. Okay, this will be takes place in presence of catalyst. So anhydrous aluminum fluoride as a catalyst. So here CH3, CH2, CH2. Okay, CH2Br, 2 of hydrogen and 1 will be bromide. If this Br shift to here, then what happened? One hydrogen will be shifting here. So just rearrangement. Rearrangement leads to the formation of different molecule. Here 1 bromo and here is 2 bromo. One here 1, 2, 3, 4. 1 bromobutane. Here 1, 2, 3, 4. 2 bromobutane. So this leads to formation of the different compounds, different arrangement of migration of atoms leads to new compound. That is what they call as rearrangement reaction. So it takes place in presence of anhydrous aluminum fluoride. Are you getting? So in first part of organic, so we'll be discussing till the types of reaction. Okay. Next, in the second part, in this, especially for the further part, we'll be discussing qualitative and quantitative. We'll be discussing later. Then we'll enter to hydrocarbon, the next chapter of hydrocarbon. Okay. So we'll continue in the next class, next session. Thank you.